All right. Good morning, everybody. I'm Jason Stoker with the USGS. I work on the 3D elevation program, and what I'm going to focus on in this part of the session is a little deeper dive into that 3D national topography model vision that Kevin set up for us. Before I get right into the 3D national topographic model vision, I wanted to take a step back, and Kevin mentioned this overarching concept of a 3D nation. Which, you know, our tagline is building a modern elevation foundation from the peaks of our mountains to the depths of our waters. And really the idea there is we want to get elevation measurements for every square meter of this country above and below the water surface. Kevin set this up pretty well for us here on the 3D national topography model. But to take a little step back, in the past when we had those topo maps that were mentioned earlier, the hydro and the elevation were created simultaneously and compiled. Over the years, when the 3DEP program and LIDAR started being filtered into the National Elevation Data Set, we had newer, higher resolution, higher accuracy elevation data compared to the hydrography data. So the concept of this 3D national topographic model is to really build on the foundation that we have with elevation and create the elevation and the hydrography together. So we have these four development tracks that I'm going to go into in a little more detail. We have some other things that I'll mention as well, but first let's go into the development tracks. The first track is really to, finish what we started, complete our foundational baselines for both elevation and hydrography. Kevin already mentioned, at the end of fiscal year 21, about 84% of the nation had QL2 or better data. This map's a slightly updated one from the one he showed, because the areas in bright green on this map are the current partnerships that we have going on from this FY22 BAA process. Talking about the, where we are right now in terms of the 3DEP baseline, I have a paper that's in review right now, but I pulled out some interesting statistics from it that I thought you all might find notable. So as it relates to the point cloud data, we have over 39 trillion points available, and those points span over 1,700 projects. The original source data, because every one of these projects is collected individually, if you think of 3DEP as a single thing, the original source data has over 37 different coordinate reference systems. You all like to be special and unique, and it makes our jobs a lot more difficult sometimes. 79 different generating software packages you'll find when you look at the 3DEP data as a whole. And then looking over all of the projects, the median point densities for all the projects is around 4 points per square meter for all the points available, and around 2 points per square meter for the ground points, which is in line with what we wanted to see for QL2 data. We repeated a study that Dean Gesh did back in 2014 to look at the vertical accuracy of the entire 10-meter seamless data. And back then, the RMSE was about 1.5 meters, and now with all of this new LIDAR that we've been incorporating into that 1/3 arc-second seamless LIDAR, the RMSE's dropped down to about 82 centimeters. And so we're positing that when we have that entire map filled in with green and we look at the elevation data compared to those OPUS checkpoints that we used before, we should get down to an RMSE of around 35 centimeters for the 1/3 arc-second seamless. And if you want to look at the individual 1 meter data, we're estimating that we'll get down to about 13 centimeter RMSE across the country. Now I'm gonna move to the hydrography baseline. So by the end of fiscal year 21, we reached 86% of the nation complete with this NHD plus high resolution data. The goal to complete all of that is by 2029. And that may sound like, not very, very far of a way to go from 86 to 100%, but most of our work is now focused in Alaska, and that's going to take a lot of effort there because Alaska is a huge challenge. One of the things we recently did is we combined the benefits of our current 3DEP and our current hydrography programs. Those were based on the 2012 National Enhanced Elevation Assessment and the more recent hydrography requirements and benefits study. And you can see here we have a combined annual benefit of both the elevation and hydrography estimated at about $1.2 billion. As those of you that have seen the way that these studies have been organized by business uses, you can see that the top business uses for both elevation and obviously water are water resources, flood risk management, natural resources, and so on. So now I'm going to move on to the second development track, which is the actual piloting of this integration of elevation and hydrography together. On the left-hand side, you'll see there some of the piloted areas that we have done on inland bathymetry. So we've been working on collecting both topobathy LiDAR as well as integrating in acoustic sonar data to get us this continuous three-dimensional surface above and below the water. On the right-hand side there, you can see we're using the elevation data that we've been collecting to create Z-enabled hydrography. So we take the elevation values on the hydrography and attach it directly so we can have a three-dimensional hydrography system. So Kevin kind of went over this, so I'm gonna glance over it pretty quick. But the third track is for us to design and implement both the next generation of the national hydrography and elevation data. We have this 3D national topography model call for action on the 3D hydrography program in progress, and we're going to be developing the Part 2 report, which is the next generation of 3DEP during this year. So I think Kevin showed this slide as well, but the big thing for us is the integration of the elevation data and the hydrography together. So we're going to be using the elevation data as a framework to improve the accuracy of both the line work and the temporal resolution, because those lines, depending on where you are in the country, could have been digitized back when you saw those topo maps created. The new data will include connections to groundwater, the National Wetlands Inventory, and even engineered hydrography data where we can provide it. And the other thing that we're going to try to do is use this hydrologic framework and turn, it's a component of what we're calling the 3D hydrography program's infrastructure, which ties into something that they call the Internet of Water. So basically what they're looking to do is use the stream reaches that have been developed for the National Hydrography data set as an addressing system. And then with that, you can tie in any related information to that network and have it used to query and do analysis and so on. So the 3D National Topography Part 2 plan for the next generation of 3DEP really depends on the completion of this national elevation requirements and benefits study that we're working on with NOAA. The study is in the process of documenting and analyzing the needs of 45 federal agencies, all 50 states, and samplings of other sectors. Those of you that were involved in NEA probably were also involved in this new 3D Nation elevation requirements and benefits study. And with the information in that study, we're hoping to use it to get a better idea of what kinds of new technologies can we use to achieve these requirements that people are saying they need. And so the way that this is going to differ than what we had before with NEA is we took a technology agnostic approach, and now we're going to look at what people wanted and see what kinds of technologies are out there that can meet the goals here. So multi-modal is really the term that we've been using for this, and we're going to be looking at a wide range of sensors. Obviously, we talked about topobathy LiDAR, acoustic sonar, because in areas on the water that topobathy LiDAR can't penetrate, we still want that elevation information. So we need to fill in those blanks with something like acoustic sonar. We're looking at digital stereo models, or digital surface models from satellite stereo data. Brian, in a few minutes, is going to talk about some of the progress we've made piloting that. Things like SAR and INSAR, knowing where things have changed so we can target high-resolution acquisitions, is another thing that we're going to be focusing on. Other tools like mobile LiDAR, where the needs are extremely high along urban corridors and transportation networks. We envision probably needing to start bringing in some of those data as well. UAS and ground-based terrestrial laser scanning, it will probably have a home that we'll be using for 3DEP. More than likely, we see those smaller areas being used as a calibration and validation instead of having to validate your data on a single GPS checkpoint on the ground and using that single value. You can now look at comparing 3D to 3D above and below the ground features to get a better understanding of how good the data is, not just for the bare Earth. Another thing in there, you'll see stratospheric LiDAR. We're trying to look at other creative solutions to get comprehensive data across the country. So getting up into the stratosphere, having platforms that can collect LiDAR or three-dimensional data over large areas and get that data to us in a timely manner so we can try to look at it either for change detection or just getting an updated snapshot of large areas. And really our future portfolio is going to depend on the cost and benefits that are documented in the 3D Nation study. So the 3D Nation study, if you guys haven't heard us talk about it before, it's a pretty comprehensive study that we've been working on for several years now. We've gathered, like I mentioned, tech agnostic information, and we're hoping that the report for this study will be released sometime this spring or summer. I'm going to show some previews of some of the information that we've been able to glean out of this study already, but these just note that these numbers are kind of subject to change. So this first one here talks about the what is it? Let me see. Okay. Sorry, I need my glasses. The types of 3D information that we are interested in here. As you can see, no surprise that the bare Earth is very important, but you can also see some of the other percentages there on the other types of three-dimensional information that people either have to have or would like to have. Let's see. Jeez. Okay. Sorry, guys. Data products. You can see by polling the people in the study, these are some of the data products that people either required or wanted to have. Thank you. And I think, DEM and DTM, the mixture there, I think USGS is probably responsible for some of that confusion because we always talk about a bare Earth DEM versus a DTM. But it was interesting to see some of the responses back on some of the things that are needed, like full waveform or ground control, things like that. I like this one because this was a question that we asked that was a little more generalized to see what the area on the ground of interest the respondents had, plus what kinds of features you're trying to resolve. So in the past, we asked, what kinds of QL levels do you need? And those were already kind of set, and so we wanted to take a step back and say, what kinds of things are you looking at, and what is the area of interest that you're looking at? And so you can see on the left-hand side there that the 3DEP domain is really focused at more of the regional level than the comprehensive level. But the focus on the types of things you can see has really transitioned from, these small features like individual trees to more survey level features such as mailboxes and so on. These are some preliminary results for the quality levels. So we did ask people about quality levels as well to see if we can match those two questions together. These pie charts here show you, the obvious trend for higher resolution data than what the original 3DEP was established with. Oh, sorry. And also the temporal component. So when we did this first generation of 3DEP, we were looking at an 8-year repeat cycle. We've seen from asking the stakeholders what they need, 4 to 5 years repeat cycle is what the majority of people really are looking for. Inland bathymetry is an interesting one because we have different established QLs that we're using from NOAA and U.S. Army Corps of Engineers. But you can see here that the trend for needing inland bathy information is really at a pretty high level. And the majority of repeat refresh rate here is similar to 3DEP, which is around 4 to 5 years. Finally, moving on to the future integration, which was the research and develop this 3D data model. How are we going to integrate all of this data, both on elevation and hydrography together? This is really a research question still for us right now. We need to figure out how do we want to package this up. Is it an HDF type file where everything comes together? Is it a series of APIs from these disparate places that all connect that we can bring into one place? How do we tie this data integrated in with things like groundwater, stormwater, things that the modelers really need to happen, and they've been having to make those connections themselves. And then obviously, this data has gotten so big that using things like high-performance computing, cloud computing, AI machine learning to handle this large data is becoming more and more a necessity for us to work at the scales that we're looking at. And the last thing I wanted to mention on the research and development is something that I've been really interested in for a while is after we have this once-over baseline collection, change detection is going to become something that's going to be critical for us. And in order to do change detection correctly, you really need to know the uncertainty of both your pre and post whatever event data sets. And every sensor, every data set, every project has some level of uncertainty. The mistakes that we often see is that people attribute that 10 centimeter RMSE value that we quote to the entire project, and we know that's not the case. So being able to take some of the lessons that the coastal topo bathy teams have done and provide per point uncertainty based on the sensor information itself, and then as well as the developing routines to calculate uncertainty of the derived raster products. Being able to use those to understand what your data can and can't tell you so you don't get yourself in trouble claiming that there's a detectable change that the uncertainty in the data just can't support. And so I'll stop with this graphic. I think Kevin had this one as well, so I'm not going to do too much about it. But this is really the 3D National Topographic Model vision that we have to move forward. Is the critical part is integrating that elevation and hydrography data together and get that to operating in a way that people can make the most benefit of both of those data sets and hopefully the value that you get from one or the other, the value you get together is exponentially better. And so thank you. I'm sorry I'm losing my voice. I've been talking to everybody so much this week. I forgot what it's like to talk for hours, and as Carla mentioned, having to talk over noise and things. But it's really great to see everyone in person, and I thank you for your time. Up next, we've got Brian Hadley, and Brian is our newly acquired draft pick that we got, who is our new data acquisition coordinator. Brian's going to give some updates on our data acquisition plans. So, Brian.
Thanks, Jason. All right, we're going to just talk about the acquisition program a little bit here. All right, as Jason mentioned and Kevin mentioned, The goal of 3DEP is to complete acquisition of nationwide LiDAR, IFSAR, in Alaska to provide the first ever national baseline of consistent high-resolution elevation data, including both bare earth and 3D point clouds. The first full year of the 3DEP program production began in 2016, and the 3DEP is based on results of the National Enhanced Elevation Assessment, which Kevin also discussed, that was completed in 2012. The study identified more than 600 different requirements for enhanced 3D elevation data to address mission-critical information requirements for federal, state, tribal, and local government and private sector companies. Since its inception, 3DEP has been built on partnerships, a really important theme of the 3DEP program. There are two primary paths for LiDAR data acquisition via 3DEP. The first one is that the USGS and other federal agencies may partner directly through interagency agreements. And the second one, which more of you are probably familiar with, is the broad agency announcement, or the BAA, which is the Vehicle for Soliciting Partnerships with Non-Federal Entities. The BAA outlines a fair and equitable process that allows federal, state, tribal, local, and private organizations to propose data acquisition projects. Together, the two acquisition streams form the 3D acquisition plan for the year. Coordination for 3DEP is managed through several layers of governance. The USGS and NOAA are co-leads of the elevation theme under OMB Circular A16 and collaborate on joint governance for terrestrial and bathymetric elevation data. Federal coordination for the program is managed through the 3DEP Executive Forum and the Operational 3DEP Working Group. The Executive Forum provides strategic direction and oversight to 3DEP and the 3DEP Working Group. And the 3DEP Working Group is really where the coordination and planning and implementation of 3DEP data acquisition takes place. The 3DEP Working Group coordinates with the Interagency Working Group on Ocean and Coastal Mapping and the 3D Nation Elevation Subcommittee of the FGDC to ensure that plans and strategies are well integrated across the different agencies. There we go. Collaboration is further strengthened through the implementation of federal best practices developed through the the 3DEP Executive Forum. And 3DEP also coordinates closely with members of a great partnership for us, which is the National States Geographic Information Council, or NSGIC. NSGIC has also published a similar set of state best practices for 3DEP, which it provides along with planning guides and templates for state planning on an information hub available via their website. So let's look at the status map. All right, current status. As Jason and Kevin have noted, we are currently at 84% completion, or projects that have been initiated at the end of FY21. We are now working on establishing our FY22 partnerships. And those projects are shown on this map in the bright green color with the hashed line on it. We anticipate that more projects are going to be coming in the future as annual budgets and whatnot get worked out as we move through the course of the year. Some data trends. What we are seeing is an increase in requirements for QL1 data. As Kevin noted initially before the program started, we had mostly QL3 data. The NEA study indicated that the best return on investment would be achieved by collecting QL2 data for 3DEP. However, the program has really seen increasing requirements for the QL1 data, which increases the cost to complete baseline coverage, but meets the needs of current users. We are now seeing that some states actually have their statewide plans that include exclusively QL1 data. And another challenge that is coming up is that we are seeing the program is seeing requests for repeat coverage. before the baseline for the western states is complete. And so you can see the fractional breakdown here. In FY 2021, we are seeing as I said, a larger demand for the QL1 data. So completing the baseline, we are looking at different partners and different applications. One of the emerging applications, which is becoming a big deal, is broadband. And so we're looking at partnerships for permitting, design, and siting for broadband. The Federal Communications Commission, the FCC, has identified requirements for QL1 data for siting, signal propagation modeling, and analysis. And this includes the potential impact to wireless signals from future development and vegetation growth. I think we got out of order here. There was the baseline. Back to the broadband. Additional support for application of LiDAR data for broadband comes from the Task Force for Reviewing the Connectivity and Technology Needs of Precision Agriculture in the United States. The task force has recommended that the FCC work with the USGS to integrate the use of 3DEP data and broadband mapping processes. They recommend that the FCC participate in 3DEP governance by assigning representatives to the 3DEP Executive Forum and the 3DEP Federal Interagency Coordinating Committee as it stood up per the National Landsides Preparedness Act. They would also like to add a member to our 3DEP working group, and we're hoping that that will get done in the near future here. And the last thing we want to talk about here is digital surface models. And we have a partnership that is established with the National Geospatial Intelligence Agency. FY20 and FY21 appropriations have been provided in the amount of $3 million to produce digital surface models for the U.S. and territories that have not been mapped by LiDAR. And you can see it's mostly in the West, and we have some of the Pacific Islands, including Palau, American Samoa, and the Mariana Islands. And the dark blue are areas that are going to be completed with 2020 data, and the lighter blue will be 2021. This is going to be done through the use of commercial optical satellite data, and we're going to be producing a 1-meter DSM product. And Jason is going to do some evaluation of that product against other 3DEP data sets to determine what sort of differences exist between the DSM that's coming out of this different mapping process with the commercial satellite data versus some of our other 3DEP data. And so the plan is to release some of that data in early 2022, and we will be publishing that data on the national map with the hope target date of the spring of 2022. And this last slide is up here to show back to the theme of partners and how important the partnership process is. We have partnered with, the 3DEP program has partnered with over 300 different groups over the years since the program started in 2016. And the success of the program to get to the baseline being 84% complete would not be possible without all of these partners, which a lot of them are you folks in the audience. We appreciate you very much. And we will be working very hard to continue to map out the rest of the baseline and move into what will be the next generation of 3DEP in the future. Thank you very much.